I think we covered this with Jörg, but
No, we did.
So one of the problems you have with handling an aircraft through all phases of flight is you need to meet the torque output requirements first to be able to handle takeoff and landing, which are some of the most dynamic motions that an aircraft has to go through. You also have to be able to switch between your redundant actuators at a very high level of integrity. And many systems that are designed today, there's an expectation that there's a human there, that if something goes wrong, they can press the AP off button and then hand fly the plane. This is obviously not acceptable for us. It's especially tricky too because when you're talking about test flying with a human being on board in a dynamic event such as a landing, when they press the off button, that thing, you need to make for damn sure the thing shuts off. And when we looked in the open market, we can cut out the damn. When we looked in the open market for what was available, commercial off the shelf, there really is not an when we looked at the open market, there really is not an off-the-shelf actuator that can there really is not an off-the-shelf actuator that can meet the torque output or integrity requirements that we needed to meet. So we decided to bring that development in-house and do it ourselves.
As far as the avionics go, is there anything you wanted to add?
No.
What about the software?
I think we touched on the software.
The last thing would be the simulation practices. I think we did.
I mentioned the 140,000.
Yeah.
I think that's the soundbite that I'd want for that.
Okay. So, because this is, we are making this known for this award, we're supposed to, they want to hear how did these things contribute to the improvement of performance and efficiency and safety. Do you want to touch on each of those one by one for me? Maybe we can start with performance.
So autopilots today really only can handle an aircraft through the en route portion of flight and landing. And even the ones that handle landing are somewhat limited because they require infrastructure to be installed at the airport environment. The military has been developing systems that can handle an aircraft through all phases of flight. Obviously, we've had drones for several decades now and very advanced automation systems going all the way back to the F-117 and further back than that. The key challenge that we had to face and where I believe we're pushing the envelope in terms of the performance of systems that go into aircraft is in doing this in a way that is certifiable for civilian use. No one has yet attempted certification of what is really a full authority autopilot that can manage an aircraft through all phases of flight.
And efficiency.
Do the safety next. So when you have a human pilot on board a plane and you have a failure in an automated system, oftentimes your fault tree ends in a node that says the pilot will recognize the fault and they will intervene and hand fly the plane or transition the plane into some other different fallback automation mode. If you don't have a human on the plane, you need to be able to catch that with some other system and be able to manage the fault fully automatically. I believe a system like this, or we believe a system such as ours, is going to make aircraft dramatically safer because when there is an issue, our system will not only recognize it faster, but it will be able to respond to it faster. In terms of efficiency.
But that's more of safety, right?
Yeah, I was trying to answer the safety one.
What would efficiency?
Well, actually, sorry, back on safety for a minute. I know
We didn't even go into safety yet, did we?
We got a lot of safety with Jörg.
Yeah.
Or I mean with Robert.